Hello, everyone. We are welcome to the 14th class out of 16 classes for Introduction to Data Analytics, SQL, and Python. We have started Python in yesterday's class with the installation, in our last video with the installation. Today, we are going to touch briefly on the installation again and going straight to learning about Python using Jupyter notebooks on Anaconda. Okay, so I'm going to share my screen now, and I'm going to talk about some things, some of the features of Anaconda and Python so that we are familiar with it. Okay, so right, so Python is object-oriented and used in various approaches for programming, but we'll be looking at Python generally for data science, right? And our course objective for today would be looking at why Jupyter Notebook for our Python class, and reason for Anaconda, then few tips on Anaconda installations, then looking at two popular packages in Python, which is Pandas and MATPLOTLIB. Then, if time permits, would also look at regression model. Right, so Python is very popular nowadays, and it's a high-level object-oriented language. Just like I said, it's used for algorithm and software creation, but it's also very useful as a procedural scripting language, which most data scientists would need to write scripts to manipulate and process data. It has become very, very popular, and another language just as popular as Python is R. Both are actually popular because they have very massive amounts of libraries and packages that can be used for data science related functions and problem solving. Right, so our focus for this course really is just to look at Python and the necessary libraries that are related to working with data. There are several libraries in Python. So for you to learn Python is just for you to learn how to use those libraries. And whenever you need to do most functions in Python, you need to know how to call on those libraries, right? So libraries generally are just objects really in software, objects in software algorithms that are reusable and contains functions to perform certain operations. So you need to get familiar with the concept of library. Right, then for Jupyter Notebook, for Python, just like every other programming language or software creation environment, you would always need what we call IDE. Just like for SQL software, we needed the Management Studio IDE to launch the software, right? The difference is because generally to program a computer, you need to write to it in some languages. So there is low-level language, there's high-level language. For high-level languages, the compiler in that software application translates that high-level language into low-level language that computers can execute. Now, generally speaking, high-level languages or algorithms would be written at the level of command prompt. But For better user experience and graphic user interfaces, we have what we call integrated development environment, IDEs, that enable software creation on friendly user interfaces. So same thing for Python, same thing we have for SQL, same thing we have for C#, same thing we have for as many programming languages that you can name. So for Python, we also have several IDEs, right? Because Python has become popular. So of course, many software organizations would like to develop IDEs that can run Python, right? So MS Azure is also an IDE. I know someone mentioned is running MS Azure. We also have PyCon, we have Eclipse, we have some IDEs that actually come with Python default installation, right? But we considered using Jupyter Notebook. Jupyter Notebook is not really an IDE, it's just a simple text editor that allows you to do much more than just executing Python scripts. And Jupyter Notebook runs on Anaconda. So Anaconda is an IDE, but does much more than an IDE because it contains many other softwares that ships with it that is used in the data science environment. So I'm just explaining this so that you can know the difference between Anaconda and every other IDE you might see running on other people's laptop who are using Python as well. So just need to understand that, okay, for Anaconda, it's easier to use various data science software platforms. Even on Anaconda, you have R, you have Orange mining, some kind of other visualization tools for running machine learning models. So I just preferred that to use Anaconda and Jupyter for this class. Then it's also easier to install and to also teach with, because in Anaconda, Jupyter, you can run each line of code simultaneously, and then the environment looks a bit friendly, and it also comes with a lot of pre-installed packages. Okay, so another alternative to Anaconda is running notebooks on the cloud environment provided by Google. It's known as Google Colab. So let's say you, for some reasons, you don't have Anaconda installed on your laptop, but you have access to the internet. You can also run, you can also load Jupyter Notebook from Google Colab. To get to Google Colab, you simply use this URL on my screen, collabresearch.google.com, and sign in, right, to create your notebook. Then the beautiful thing about Google Colab is that it can connect to your data on the cloud, either on the Google Drive or in some databases in the cloud, as long as you have the data connection specifications and you have access to that data. So for very, very large data projects, sometimes we consider using Google Colab for executing such projects. Okay, nice. So for you to install Anaconda, it's best that you download the software from Anaconda websites themselves. And then this is the website on the screen. So you just go to www.anaconda.com slash products slash individual, and this lands you in this page similar to the screenshot you have on my screen, and just simply download the latest version of Anaconda. So Anaconda is in huge support of Python, and you can see that it comes it comes with a default installation of the latest Python version 3.8. So once you don't need to install Python if you're installing Anaconda, because Anaconda will just on default install Python for you. And you can even go into Python IDE, some other Python IDEs directly from Anaconda. There's Eclipse on Anaconda, right? But we'll be using Jupyter Notebook. Okay, so once you install Anaconda, it's quite a straightforward process to install Anaconda, but there's a particular tip you must ensure to follow when installing Anaconda. Ensure that your installation folder, which would be specified at default during installation, does not contain a space. So if your default program file contains a space, which usually is the case, then it's preferred that you create a new folder for you to install Anaconda on. It would even show you that tip while you are installing, because if there's a space, it's likely to give some errors while trying to install some packages on your software. So just follow the prompt. Once you download the executable file, just execute and follow the prompt, then take note of the tip I just mentioned. All right, so once the download is completed, you can launch Anaconda from your start menu, and launch Anaconda Navigation from your start menu, and then you would then see Jupyter Notebook icon. So just click on it, and then it will load Jupyter Notebook for you this way, right? As you can see on my screen. Right, so, okay, let's load Jupyter Notebook so that I can alternate between this. Okay, just a second. Oops. Sorry, I'm going to share my screen again. Okay, I needed to exit full screen mode, and it stopped sharing my screen. Okay, so I'm going back to, let me share the whole of my screen. Okay, right, so assuming we have installed Anaconda, to call up Jupyter Notebook, we are going to go to our start menu. You're going to see Anaconda installation as a folder from your start menu, which contains many options. You have the Anaconda Navigator, you have the PowerShell prompt, you have the Anaconda Prompt, Jupyter Notebook, and some other features. So let me click on the Navigator. So once I click on the Navigator, it's going to load the welcome page of Anaconda for me. So while trying to open Anaconda, it comes up with various command prompts like you saw, right? But you just ignore them and allow Anaconda to load. Okay. Okay, so this is what the welcome page of Anaconda looks like. Just like I mentioned to you, you have some various data science tools that are all combined in Anaconda. But our focus is Jupyter Notebook, and this is our Jupyter Notebook. Right. Once, if it's a new installation, you would see it as launch. So if, if it's already installed, you see it as launch. And then some other tools that ship with Anaconda that are yet to be installed, you see them as install. So if I want to use any of this, let's say I want to write R code, I can come and install R Studio. If I want to use Orange software, I can use this. Right, so for me to launch my Jupyter Notebook, I can come here and click launch, and then it will load my Jupyter Notebook for me. Another alternative way of loading the Jupyter Notebook is to simply click on Jupyter Notebook from your start menu here, Jupyter Notebook, or come to your Anaconda Prompt, which is preferably what I would want to use, and type Jupyter space notebook. Right, so once I do this, my Jupyter Notebook is going to launch. So Jupyter Notebook would usually launch in a local host. It will usually launch in an Internet Explorer, usually because it will launch in an Internet Explorer using your system's local host. It will pick the local host by default, so you don't need to worry about it. So this is my Jupyter Notebook environment. Now, most times it will default to run from your C users document environment. This is what I mean. Okay, let me open a new Anaconda prompt. Okay, right. So if you look at my Anaconda prompt, in the first line, you see a file path, and then written with base here. So this simply means that the Anaconda files running on this system is going to run from this location on my system, right? I may decide to change where I want the Anaconda files to run from. And to do that, I'll just simply use the cd command. But I can only do that from the Anaconda prompt. So I can say cd, then put a new folder name. So I've created a folder where I want my, let's say I want all my projects to run from a project folder I've created. So I'm just going to copy that path. Then on the command prompt, I'm going to change that location from the default location and say, run my Anaconda from here, right? And then here I'm going to say Jupyter Notebook. Right, so you can see that this is different from what we have. Oops. Okay, you can see that this environment contains some other, it's from my C users, it's showing me all the folders in my users document and some other files in Jupyter Notebook that I've worked on earlier, right? So it's pointing to a different path. And of course, it chooses a different host for it. If I change my location to some other file path, it will give me another different host, right? And then there I don't have any folder. I only have one test file I've created, so it's going to show me that. So the reason is because it's always best to have your notebook or your script in a place that you know, right? Not in the default location. So let's say you're working on a project and you have a folder for your project, you want to save all your files relating to that project in a particular file location on your system. So then this would become necessary. Right, so this is what the Jupyter environment looks like. Jupyter is almost, just from the name, as the name sounds, is similar to a notepad, right? But it can help you you can write code in it, you can write HTMLs in it, you can write titles in it. So it makes your code much more comprehensive and descriptive. So it's a very, very rich text file for writing Python codes and also executing it on Anaconda or Google Colab. So now that, okay, let's just look at some features of Jupyter Notebook. Don't forget, I said your Jupyter Notebook will open for you in an Internet Explorer. Right, so the first tab shows you the list of files in the folder you are running the Jupyter Notebook from. Then here you are able to see some environments that are running currently or notebooks that are running currently. Clusters, I don't really know what that is. So for you to create a notebook file, you can upload an existing one, and then you can create a new one simply by clicking the new tab here. Right, you can see that I have Python 3, so I'm just going to click on Python 3. Okay, right, so we have our Jupyter environment for Python loaded and ready. So you have the file menu. So file menu is just to create new notebook, make a copy, then you can download your notebook as a LaTeX file, as HTML, as notebook, even as PDF, then also as Python file, in case you want to share your file with other Python users using different IDs. So it's all encompassing really. So on edit, we have different ways you can edit your cells. This is what we mean by cells in Jupyter Notebook. So each of these boxes wherein you can write your code is called a cell. So this is like cell 1. If I want to create additional cell to write the next line of code, I'll just click on the plus sign. It will generate the next cell for me, and so on and so forth. So this is just insert as well for working with cells. We are going to see how this runs by the time we start writing some interesting codes in our notebook. Okay, so I'm just going to go straight into the kernel menu. So this kernel menu, the first one, interrupt. So, okay, the concept of kernel is like the compiler. Let me use the word compiler that runs your Jupyter codes within the cell. So whenever I click run here, the kernel starts executing. So if I have a long list of code and I want it all to run concurrently, I can just click run and all will run, or I can put my mouse in the current cursor, in a specific cursor, and then click run. So I can run per cell or I can run all cell at once. So in case I want to interrupt the running or the execution of, when we say run, it means execution. So if I want to interrupt the execution, I can click interrupt, I can click, and then I can allow it to restart. Then restart and clear output means to rerun the cells and clear all the previous results. Then you have restart and run. Then you can disconnect your kernel. Of course, if you disconnect your kernel, your codes are not going to execute. So you can disconnect, you can shut down, you can change kernel if you have more than one kernel. So sometimes you can have things like your GPU or TPU kernel that enables your very high processing running or execution of your Python code. So that's, well, in this case now I have just Python. So here I can change kernel if I have some other GPU or TPU installed. You might not need to worry about this, but it's very important I explain the concept of kernel to you. That's why I've explained this to you. But as you do more in Python for machine learning projects and the rest of that, you would see the importance of kernel. Okay, so we are just going to stop at that. So I'll leave widgets and help out. Those are things you can find out later on our own. Then, oops. Okay, right. So you also have some icons below here. So your Jupyter notebook comes with a default name, which is Untitled. So if I want to change the name, I can click on, okay, no, if I click on save, it will save whatever I have as the name. But if I want to change the name, I'll bring my mouse to where we have Untitled, click on it, and then I can change the name. So let me call this Python class 1 and rename. Right, so this is my file name, right? And I can come here to save from time to time. Then this plus sign is to create new cells, right, for writing your codes. Then this scissor sign is to cut selected cells. So you can see I need to be in a particular cell, and then once I click, it can cut on the cell. This is to copy selected cells and paste, right? So I just use copy and paste. Then you can move up and down between cells. Then if I have anything here, let me say, let's use the popular first, let's say to print, we'll just say, okay, so I have a simple print code here. So if I want to execute, I'll just click on run. You can see it as executed. Let's say I have another one here. I'm just trying to write a little more complex print. So, hello participants, we are welcome to the 14th day of free training on data analytics. Okay, right. So I have two cells here. The first one is executed. So in the second one, I've just declared a variable A containing the integer 14 value, right? So in Python, you can explicitly declare your variable, and you can declare it this way to still automatically just assume the type to the variable you have declared. So I can write it as A, I can write it as int A, right? So let me remove the int, let's write it as A. You don't need to specify end of statements in Python. Each statement written on a line is taken as a complete statement. So I have A equals 14. So on my second line of statement, I have hello participants, you're welcome to the, I'm doing like a concatenation of string here. So it's going to pick my value here, right? And write out this complete statement for me. So I'm just going to click to run. Okay. I need to convert this. Oh, okay, let me use the comma and see if it will allow me. Okay, right. Okay, so print statement actually allows plus, but in that case, all the string types must be the same. Okay, let me see. Let me confirm what I'm saying. Let me say, let's say I wrote 14 in string. Let's run this. Oh, right. Okay, great. Okay, so you can see from my screen that print statement allows plus, but in that case, all the values must be of the same type. So if I'm using string values, then I needed to have converted this into a string. But in this case, I want it to be as integer. I don't want to do any conversion, so I just use a comma. So you can see how we have in this cell declared a variable and given the value, and then we have used the print statement to indicate the value, right? So to execute, you can see I'm just simply clicking the run. Now you notice that as I'm executing, the line is changing. So I have line 1, I have the value, I have line 5, it should have been line 2. But because I've executed this like 4 or 3 times, it's already updating as line 5. So in Jupyter Notebook, every code you execute is taken as a block of code and then logged as a line or logged as a cell line, right? So of course, let's just click this again to save. If I'm here, I can use this plus sign to insert a new cell, right? I can use this copy cell. I can use this to toggle my cell movement. Let's say I want this to come back up, right? So you can see, I can move it back down, right? Then run, I've explained run. You use that to execute. Then run is to initiate the kernel, right, to execute. You can stop your run or interrupt your run using this stop button, right? So you can see it's interrupting the kernel, or you do it from the menu here. right? Then you can use this to restart the kernel. So if I want to restart the kernel, it simply means that it should rerun my code from the very beginning. So if I click this, it will give me a warning and ask if to restart the kernel. If I say yes, restart, you can see it has restarted and it has run every of my cells. So you can see this is one, and then the next line or cell of execution is this, which is 2. I can use this to take out the cells that are empty or are not needed. So that's the general understanding, right, of your Python environment. You can see it's very easy to grasp. The last thing I'm going to explain is the types of cell. So remember I told you each of this is a cell, and you can have like 4 types of cell. A cell can contain a code, it can contain a markdown, can contain a heading, can also contain this NB convert. Most times I've not used this NB convert before, so it's not something you commonly use. But here is the explanation from my script. From my slide. Right. So the code type of cell is used to write code, and we have just demonstrated that. Then heading is usually designed for your titles, but you can do that easily now using what's this hash symbol. I'm going to write some headings and then I'll show you how it is. Then you also have the markup language, which you can use to write any kind of HTML code for those who are familiar with HTML tags. So, right, let's go back to our notebook and just try out some of these cells. So let's create a cell. Let's take this cell up. So I'm going to change this cell type to, let's change it to heading, right? So you can see once I selected heading, it just automatically gives me an heading with the hash tags or hash symbols. So wherever I write, of course, I must not remove the hash. If I remove the hash, it automatically reverts it to a cell type. So I'm just going to write this. Oops, sorry. Okay, let's say okay, then come here and write the heading. Okay, so you can see our heading. So you can see if I automatically remove the tag, the hash symbol is going to clear out my heading. Come in, let me. Okay, so we can use one hash for title 1. Okay, right. So if I use 2 hash, okay, right. So that's that for heading. Then of course you can use heading also. You can use the hash sign for commenting in Excel. In Jupyter Notebook. So let's say I want to comment on my code. So I'm just going to write the hash sign, just the same way we were using commenting in SQL. You can as well use commenting here as well. So I can say print hello world. I'll first Okay, right. So you can see description, right? Or comments in code, right? So it's always nice that your codes are descriptive. Whenever you write a line of code, you might want to just put a comment to explain what that line is doing. It always helps, yeah, because if you come back to that code, you can remember, or if someone else is reading your code, they can understand what you were trying to achieve. Okay, right. So that's that on Jupyter environment. Let's go back to our slide. And now that we are familiar with Jupyter environment and notebook on Anaconda, I'm just going to talk a little about packages. So for almost anything you do in Python, you are going to call functions. So for procedural scripting generally, you would need to get the functions that will execute the operation from a library. So libraries are also called packages, and you need to get familiar with them to be able to use them on your data. So for our purpose of data analysis and for data sciences, the common packages that you would use most of the time in Python are the ones I've listed on your screen. There are many more, but these are the common ones which would also treat in this course, right? You can learn as many more when the need arises. You don't even need to learn all the packages. Whenever you need to perform an operation, you just Google and check the right package for it, and know the check for similar functions that you need to call in it, and then just import the package and call the function. So we are going to start off with Pandas package or library. So it's used for data manipulation and analysis. We are going to do Pandas and MATPLOTLIB for today. Right, so Anaconda already comes pre-installed with Pandas, but for just in case, or for people who might not be using Anaconda and on some other environment, you might need to install the package. So to install any package in Python generally, you use the pip keyword, and you can install in various ways. You can install once Python is installed on your computer, maybe through Anaconda or on a separate Python installation file. Once Python is installed, your computer automatically detects the installation, even from Windows command prompt. So from Windows command prompt, you must know, oops, sorry for this spelling, you must know where the Python is installed, and then you must change directory using CD to that path, that file path, then you can issue the pip command. If you don't change directory and you issue the pip command, it will not work because Windows will not recognize it. So I don't usually recommend this option for installing Python packages, because sometimes you might find it difficult to know where your Python is actually installed. Another option is to call up Anaconda Prompt. You would find Anaconda Prompt from your folder, from your start menu folder of Anaconda. There are actually 4 or 5 things you find there. So one of them is Anaconda Prompt. Right, so once you click on Anaconda Prompt, it loads a command environment for you. Remember I showed you how to change your Jupyter notebook save location from here, simply using CD, right? So from Anaconda Prompt, actually, whether you change your Jupyter notebook path or not, you can just use the pip command straight from here to install. So let me show you how to write it. You just write, it's just a simple syntax. It means pip install whatever package. So let's say Pandas. So I already have it installed. So let's see what to come up with. So you can see Pandas is already pre-installed with my Anaconda, and then it will give me information, feedback that requirement already satisfied. It already has Python, Pandas in it. I can install some other package as well. Assuming I want to uninstall the package, I'll simply do pip on install, then the package name, right? So I'm not going to run this because I don't want to uninstall. If I want to upgrade the version of my package, sometimes you might be running some code and then there might be an error to say, oh, this function you are looking for does not exist in this version of the library, that you should install a newer version. So to upgrade on to a newer version, you just do pip install upgrade, then the package name. So pip install upgrade pandas, and right, it would then upgrade for you. So of course you need to be on the internet for it to be able to do the upgrade. So you can see that it just upgraded my pandas library, even though there was no need for that. The operation is still continuing. Once it is done, it will then give you a successful message, but you can see it still. Let me see. Okay, yeah, I already have the latest version, so yes, that's why I'm having this error, right? But that's just the command to issue to upgrade your package, right? So you can pip install, which I just demonstrated. You can also do that pip install from your Jupyter notebook, but if you are to pip install from Jupyter notebook, you need to include the exclamation sign. So let's try that. Let's go to our Jupyter notebook. I'm going to put a comment here because I'm going to send you this file so you can practice. So let me put a comment. So how to install packages from the Jupyter notebook. So I'm going to do pip install here, but I have to start my pip install with exclamation mark. So pip install pandas. So now if I execute this, right, so it's running, and whenever it's executing or running, I wasn't fast enough to show that. Whenever it's executing, it will show you an asterisk sign. Okay, let's run this again. So whenever a cell is busy with execution, instead of showing you a number sign, it will show you an asterisk sign. So you also need to take note of that. So you can see on my screen is showing an asterisk sign, right? So this is already installed, and you can see from the display. Okay, so that's that on how to work with packages. And for everything, for almost anything you're doing, you need packages. You can also specify the version if you know the version you want to install. This is pip install scikit-learn package, specifying the version. Then I've demonstrated this to upgrade. So upgrade will just simply get the default version. Okay, so let's go to our next page, the slide. Okay, nice. So let's install, let's make use of our Pandas package to work on some data. Right, so for every package you install, before you can use them in your Python environment, whatever, irrespective of the IDE you are using, you have to issue the command import. So import is just like a way of adding the library to your current file. For those who are familiar with software development, generally codes are reusable. You are not expected to write all the lines for the code for an application to run. Instead, you don't need to reinvent the wheel. If there's a software block somewhere or an algorithm somewhere that is doing similar thing you want to achieve and is embedded as a library, and a library is just like an executable file, a DLL file, you can just install that software and then add that library, or just add that library directly to your project. So in similar vein in Python, once you have installed the package, you need to import, or in the same vein, add that library to your current file. So to do that, we are just going to issue the command import the library name. So in this case, our package that I want to import is Pandas. So we are going to use the concept of alias we learned in SQL here as well when importing. So when importing, you're going to import as an alias name. So when next you want to call on this library, instead of calling Pandas, you're just going to call the alias name. So the alias name can be anything, but most times people just popularly use PD. So PD has become like a nomenclature for Pandas. So people will just do import Pandas as PD. But your PD can be anything. I can write PDA, I can write PDD. In fact, let me put PDD today. So import Pandas as PDD and then run. Right, so once my asterisk changes to a number, then it means that my my cell execution is completed. Okay, let me put a description here so you are familiar. How to add a library also package into our current Python file. Okay, right. So I'm going to show you how to use PDD. So in Pandas, the two main things that Pandas offers is series and data frame. So data frame are like tables in Excel or tables in SQL. They are like matrix. You can use it as matrix. So a 2x2 column. Oh, sorry, what am I saying? A 2-dimensional table, not 2x2 column. Of course, it can have several columns. It can have several rows. So in Python and in data science generally, instead of saying tables, we call it data sets. I don't know why, but they are just different terminologies. But it's not, I think the key thing is for you to understand what these things mean. Just demystify those buzzwords and those terminologies and understand what they are doing. So that's why I'm giving you similar names. So here in data science or in R and Python environment is called data set. And for you to work on any data set, you likely put it in a data frame. So a data frame is just your table. Yeah, just simple term for table. But it's so a data frame can contain. So there's a difference between a data frame and a matrix. Actually, a matrix must contain same data type, but a data frame, just like a table, can contain various data columns. It can contain columns of various data types. Right. Let's leave it as that. So let's create a simple data frame using Pandas and see how it's done. So let's say, again, and I also need to explain this. So in data world generally, we have the concept of arrays or variables, of series, then of arrays, variables, of series. So your variables are generally like single numbers, like your integer number or character and all that. But for you to have a list, then you must have it as a series or as an array, right? So to create then a series here in a series in Python is also seen as a column, not as a row. So let's create series and see what I mean. So let's say we are creating a series named name. So let's say we have students. Okay, let's just say names. So I have names and I want to create a series or an array. I can call it these names. Josiah. Okay, so let's stop there. Okay, I can say ages. One, two, three, four, five. 1, 2, 3, 4, 5. 5, right? So these two are series, right? Okay, so I can execute both of these into a data frame, right? So I can create a data frame as df. So this is like initializing my data frame. So I'll use my Pandas alias and then say data frame. Okay, so I have an error. I'll just scroll down to see. Pandas has no. Oops, let me see. Maybe I'm missing. Oh, okay. So Python is case sensitive. So the D has to be capital, the F also has to be capital. So this will be capital D and then capital F. And we can run. Okay, so you can see my data frame is created. So I can create this into a table, right? Using my data frame. I can only create into a table using data frame, right? So I'm going to then use my data frame that I've declared, and then I'll say df equals to, I'll just combine them. So I can combine it this way because I want the data frame to carry a header name. Okay, so if I execute this now, okay, we are missing a syntax. Let me see. Oh, okay, I know what I'm missing. So I need to specify this as string because it's a column header. Okay, so let's run this now. Okay, so instead of equal sign, it should be column. Okay, right. So a data frame is created now, and then this way as well, a table is created. Right. So for you to see the data frame, you can just simply say df, and it would show you the data frame. So this is actually a table containing column names with the name, containing column ages, right, with the ages. You can also use a data frame to merge two series or two arrays of numbers. So I'm going to show that to us now, but before I do that, let me just put some descriptions on this. Creating series or columns in Python. So it can be called series, can be called columns, can be called arrays in Python for holding a data set. Okay, right. So this is initializing to initialize a data frame. Oops. Let me run because of time. Okay, so let me go back to the slide and just try to wrap up as soon as possible. So we've covered here just to give us some brief description on how to use Pandas package, which we have demonstrated. Then we also want to see some ways on how to use Pandas package to read data files. Of course, you know it's very boring and very tasking for you to be creating your data using series or arrays and all that. Most times you already have your data in CSV file or JSON file, and you want to import it straight into your Python environment to work with it. So to do that, you simply call the function read CSV in your Pandas library. for you to do that easily, it's always best that your file is in the same location where you are running your Jupyter notebook. So remember, I'm running my Jupyter notebook from here. Where's that? From my projects folder. I'm running my Jupyter notebook from my projects folder. So I'm going to copy and paste that our US regional. Okay, so that US regional file is in Excel. I'm going to save it as a CSV, put it in here, and then bring it into Python. So let's do that quickly to wrap up this session and go into demo. So where are we? That's in downloads. I have that file in downloads. Okay, it's in Excel or is in XLS, so I want to change it to CSV. To do that is very simple. We are just going to open and save as a .csv file. Okay. Okay, so I have several. I won't just, because I have several sheets in this, it might give me an issue. So I'm just going to copy the particular table I want and put it in a separate file and save that as .csv. So I want just this others information. Why didn't this thing copy that from now? Need to select from here. So when copying, make sure your cell is on the first cell, that's cell A1, so that I can copy the header as well. So copy, then paste on a new blank file in Excel. Right, so I have my header. So I'm just going to save as CSV. Save as CSV. I want to save it in the same location where I brought it from. So to save as CSV, you just change your type here to CSV. Make sure you pick CSV comma delimited. Don't pick this UTF-8. So pick this one. So this CSV, and we are just going to save it as, you can give it any name. I'm calling it test file. So test file CSV. Right, so I have this saved as CSV now. If I come here, I can see that is a CSV file. Right, so I'm going back to my Python and I want to read that file into my Python. So I'm going to say, I'm going to declare another container for my data set that will receive my Python. So I can call this df2. So this would be pdd.read_csv, and I'll just specify my file name. So my file name is test file. Can come here and copy the file name so you don't make mistake. So this would be test file.csv. So if I execute this now, it should. Oh, sorry, I need to put this in quotes. Will it be single or double quotes? Let's try single quote first. So run this. Right, so if there's no error, it will run successfully and then the cell will change to a number. So this means that this operation is completed. And then if I go into DF2 now, if I do DF2, it would show me my file. So you can see I have my file in my Python environment now. Because there are several columns, several rows in the file, it will just show me a few of them. But of course, you can see it's showing you summary of the rows and columns. You have 7,000 plus rows, 16 columns. I can, at this point, then start manipulating on my file. Like I want to see, let's say I want to see the first few columns, then I'll call the same data frame, which is df2, and I can say .ed. So .ed will show me the first few columns. Right? Okay, I think the first 5 columns. I can say df2.tail, right, to show me the last few columns. Let's say I want to know the data types, the definition of the data types in this table. I can come here and say df2.info. You must make sure you are using that data frame, because the way it is now is like your table has now become df2. So anytime you need to refer to or do anything on your table, you need to use df2. So df2.info run. Right, so you can see it giving you information about your table, all the column names, all the types, right? The type, type in Python. So these strings are actually string types. Oops. String column types are actually seen as objects in Python. Then you have integer types and float. So you have objects, integer, float, right? Okay, so if you want to do some, if I want to see a column, I can also use df to see columns. If there are null values, I can manipulate using df. So Pandas, just helps to do a lot of manipulation on your data and analysis on your data. Oops, it should be df2. Remember, my df1 is just an array. What happened? df2.shape. Or am I missing the capital shape? Small shape now. Okay, we'll use shape some other time. So that's on
okay
file. I will stop the demo here because of time. We'll continue from here tomorrow to use MATPLOTLIB and to run our regression analysis. But I'm happy we got this key information on using DF, and I want us to actually do some more practice. Then I don't want the video to be too long. Okay, thank you for joining me in this session. See you in tomorrow's session, where we'll be doing some more analysis on our data and running some machine learning algorithm on our data. We're not going to do so much on Python, because Python is just for you to know the packages or libraries that you need as need arises, and then call and use them. But the founding knowledge of how to be able to work with Python, we already have. Then some of these things we'll be doing in Python, you could also do them on your data in SQL or even in Excel. You can prepare your data from Microsoft SQL. When I mean prepare your data, I simply mean you can clean, replace missing values, remove duplicates and all that from SQL, even from Excel if you are very, very good at using that, and then just bring it into Python to apply machine learning functions and algorithm, or just do some much more, what's it called, visualization to see your correlation and all that, which we'll do tomorrow actually. So, okay, to wrap up on the class, apart from using DF to read from CSV, we can also use it to read from JSON file type. Many of the data that you get from online usually come in JSON format. So to read it using Jupyter Notebook is very, very easy. You can read it into your Jupyter Notebook, then convert that data frame into CSV, right, and download it. So that's also an interesting way of changing JSON file formats into CSV file formats, which you can use easily on other data platforms. You can also connect Python directly to databases, either SQL, either MS SQL, or MySQL, or even Oracle databases, as long as you know the connection. So the connection would require you to, you need to set up the connection. We are going to demonstrate this hopefully tomorrow, because I would like us to know how to connect Python to SQL. And then you can read your data from SQL into Python, because in real life environments, you might likely be faced with getting data from structured databases like SQL. So you need to know how to read data from SQL. So Python is actually very, very robust and very good. It's just for us to understand the basics and then know how to pick up from using and applying it to our data projects. Thank you. See you in tomorrow's class. Bye for now.